All right, fifth grade, we are going to be on page 242 looking at some more stuff about light today. So I want to start by I want you to think for a second, like close your eyes and think about like maybe you could walk around your room for a second, see what you bump into. All right, so if you can't see, then you're going to stumble and bump into things, right? All right, so maybe give it a try for a second. Maybe get your siblings to do it with you for a little bit if you want to. You're probably really bored and stir crazy, so I'll give you something to do. All right. But anyway, so we're going to be looking at what light does for us. So without light, there is no vision. Like, you can't see anything. Also, light is what gives us color, to see things in color. So we don't just see everything black and white. We see color, all right? So let's start on page 242 at the top where it says visible spectrum. I kind of already said the first paragraph, but I'm going to reread it. If you try to walk through a dark room, you may stumble or bump into things. Without light, there is no vision. You see the objects around you because light bounces off them. Light makes things visible or able to be seen. Light also gives objects color. In 1672, Isaac Newton proved that light is made up of many different colors. Newton used a prism to separate white sunlight into a band of many colors. The different colors of light that we can see are called the visible spectrum. Refraction and reflection. Light generally travels in a straight line. The direction and speed may change, but its path will usually be straight. The matter through which a wave travels is called a medium. The speed of light changes as light enters different media. Light travels the fastest in empty space. It slows down a little when it enters air. Things such as glass or water make light slow down even more. When it enters a new medium, light slows and can bend in a different direction. Refraction is the bending of light as it passes from one medium into another. Prisms separate light into colors by the process of refraction. As sunlight passes through the air and enters a glass prism, the light slows down and bends. Each color of light has a different wavelength, so each color bends a little differently. This allows you to see the separate colors. Refraction also happens in a rainbow. Sunlight passes through raindrops and bends into the separate colors of the visible spectrum. So when you're seeing a rainbow outside, you're seeing refraction. The colors in the visible spectrum are in order by their wavelengths. The reds have the longest wavelengths. The colors after the reds are oranges, yellows, greens, blues, indigos, and violets. The violets have the shortest wavelengths of the colors. You can remember the order of the color groups by thinking of the first letter of each. The first letters spell out the name Roy G. Biv. That's like if you were going to color a rainbow, you would color it like this prism shows: red, orange, yellow, green, blue, indigo, violet. All right. So this is your example of light enters the prism and then refraction happens where it bends, and then you get the color spectrum shown there as well. All right. So refraction is one way that light changes its direction. When light hits transparent matter, the light passes through with little bending. Objects behind transparent matter are clearly seen. As light hits translucent matter, some light passes through and some is bent or blocked. Objects seen through translucent matter appear unclear. Light slows down and bends when it passes through transparent or translucent things. Opaque matter does not let any light pass through. All of the light either bounces off the object or is absorbed or soaked in. Light can also change direction by reflection. Reflection happens when light bounces off of an object. The color that you see is determined by which colors are reflected and which are absorbed. You see the reflected wavelengths as the color of that object. A red book reflects the color red. All the other colors of light are absorbed. When all the colors of light are reflected, you see white. When you see black, when all the colors of light are absorbed. So that's why, we're going to get to that in a second, but when you're outside, if you're wearing dark colors, you get really hot. If you're wearing light colors, you don't get as hot because the sunlight is being absorbed into your dark clothing. Why are darker clothes usually warmer? Darker clothes absorb more of the sunlight around energy from the sun. The sun's energy makes the molecules in the clothing move faster. The temperature of the clothing rises and keeps the person warmer. That's why a lot of times you'll notice that winter clothes are darker and summer clothes are lighter, just in general. All right, science in the Bible. God often uses light as a metaphor. In Psalms 119, 105, the writer describes the Bible as a light unto my path. Just like a light shows you where to walk at night, God's words show you which choices are right and safe. Sadly, many people do not like this light because they live in spiritual darkness. In John 8, verse 12, Jesus said, I am the light of the world. He that follows me shall not walk in darkness, but shall have the light of life. Through Jesus, people can move from the world of darkness to the world of light. And we need to be the light to other people. Especially this time right now. If you got a way to show kindness, do that. People need to see kindness right now. It's kind of depressing out there. All right, combining colors. An amazing variety of color is all around you. Whether a beautiful blue sky or a bright yellow flower, the world is full of colors reflected from our sun and white lights. Scientists study color using the idea of a color model. There are different color models, but each has 3 primary colors. Primary colors cannot be made from other colors. God designed our eyes and brains to combine primary colors into all the other colors that we see. The primary colors of light are red, green, and blue. All the colors of light are formed by different combinations of those primary colors. If red light, green light, and blue light are mixed together in equal amounts, they reflect all colors and produce white, as shown in the center of the model. Television screens and computer monitors take advantage of this color model. Tiny groups of red, green, and blue lights shining at different brightnesses can produce all the colors you see on a screen. Each primary color has an opposite or complementary color. The complementary color of red is cyan, and the complementary color of green is magenta. What is the complementary color of blue? Question mark. All right, so if we look down here, so we have our colors of light. We have red, blue, and green. Okay. The complementary color of green was cyan. Is that right? Is that what it said? I'm sorry. Gotta look back up. Make sure I'm reading this right. Complementary color of red is cyan, and the complementary color of green is magenta. I'm saying it wrong. So it's kind of like the opposite of where you see it. So red is here, magenta is here, so the complementary color of blue would be yellow. And when they all come together, you have white. All right. Most objects in the world are not sources of light. Instead, they reflect light. The colors you see are those that are not absorbed by pigments in the objects. Pigments are opaque substances used to color other materials. The primary colors of pigments are yellow, cyan, and magenta. A lemon is yellow because its pigments absorb all colors except yellow. Yellow is reflected. Notice that the primary colors of pigments are the complementary colors of light. All right, so you had now you have these inner colors on the outside, and you have the outside colors on from this one on the inside. So they're kind of like the colors of pigment are kind of the opposite of the colors of light. And then you get black in that center part instead of white when they combine. Paint pigments work the same way. You may have learned in art that the traditional primary colors are red, yellow, and blue. Pigments reflect these colors. Red paint looks red because it reflects red. A blue crayon reflects the color blue. When you mix pigments together, you do not get white. You get a dark, almost black color. This is because they absorb nearly all the colors of light shining on them. Color is a wonderful gift from God. When he said in Genesis, "Let there be light," he had already planned for his earth to be beautiful with color. He created the pigments and light to work together. He knew that a wide variety of colors would bring pleasure to people. All right, try it yourself. Many books and papers are printed by a four-color printing process. The printers use combinations of cyan, yellow, magenta, and black ink to produce all the colors you see in a book. Use a magnifying glass to look at a colored picture in this textbook, if you have one at home. And then, do you see all of the individual dots of color? The dots are so close together that your eyes blend them together. This makes the color and shading that you see in the picture. So if you were to like zoom in on your book where the printers had printed it in the printing process with a magnifying glass, you would actually be able to see the individual dots versus where your eye, like far away, your eyes just blend it all together and you don't even notice it. So, all right, well, that is the end of our lesson for today, 242 through 245. Tune in for the next lesson, which will be, we're going to be looking at mirrors and some light technology. All right, have a great rest of your day.